Before we get into the techniques themselves, it's important to understand why wood preservation during World War II became a matter of survival rather than craftsmanship. Entire nations were building barracks, bridges, supply crates, field hospitals, fences, rail ties and farm structures with limited steel, limited concrete and, almost no replacement capacity. If a beam rotted, it wasn't replaced. If a fence post failed, livestock escaped or defences weakened. Families relied on wooden homes, barns and sheds that had to survive decades of weather with no modern sealants. The methods developed and refined during this period were born from necessity, scarcity and, honestly, ruthless efficiency, and many outperform modern store-bought treatments in longevity. What makes these techniques valuable today is not nostalgia. It's the fact that wood treated this way was expected to last generations with almost no maintenance. If you care about off-grid construction, long-term resilience, or preserving structures without chemical dependency, these lessons are still unmatched. The practice of charring wood ends before burial was standard wartime engineering. One of the most widespread World War II preservation tricks involved controlled charring of any wood that would contact soil. Fence posts, structural footings, bridge pilings, and barn supports were lightly burned until the surface carbonized. This wasn't guesswork. Charred wood becomes resistant to fungi, insects and moisture absorption because the outer layer no longer supports biological activity. Wartime engineers understood that rot starts at the soil line, so they focused protection there. Today, this can be applied to garden beds, fence posts, or shed foundations by carefully charring only the buried section and sealing it with oil afterward. When done correctly, posts can last several decades longer than untreated wood without modern preservatives. Hot oil soaking, actually replaced modern pressure treatment in quite a few civilian areas. When chemical preservatives were, diverted to military use, civilians had to get creative and turned to hot oil immersion. Folks would heat up used motor oil, linseed oil, or even animal fats, and then brush or soak that into dry lumber. The heat would open up the wood's pores, allowing the oil to really get in deep. Once it cooled, the oil would harden inside the fibres, repelling water and, importantly, starving rot organisms of oxygen. These days, a modern application of this method works honestly exceptionally well for tool handles, outdoor furniture, and non-load-bearing structures. The key, really, is making sure the wood is dry before you treat it, and then having the patience to let the oil cure fully before exposing it to the elements. Limewashing wooden structures, that created a downright hostile environment for rot and insects. Limewash wasn't decorative during the war, not at all. It served as a preservative, a disinfectant, and a pest deterrent, all rolled into one. Made from hydrated lime and water, it was brushed onto barns, cellars, sheds, and even interior beams. Thanks to lime's high alkalinity, fungal growth was prevented, and insects were discouraged from nesting. Applied annually, limewash preserved rural wooden buildings across Europe for decades. Today, it remains one of the safest and most effective treatments for interior beams, crawl spaces, and outbuildings where moisture control matters more than appearance. Pitch and resin sealing was revived when industrial coatings vanished. Tree resins, pine pitch and tar were boiled and brushed onto exposed joints, end grains and seams. This technique was especially common in Scandinavia and Eastern Europe, where conifers were abundant. Resin created a waterproof, flexible seal that moved with the wood instead of cracking like modern paints. For modern use, pine tar remains one of the best treatments for outdoor structures like sheds and docks. Applied thinly and renewed every few years, it can preserve wood far longer than synthetic coatings that trap moisture underneath. You know, salt treatment really extended the life of wood in coastal and agricultural settings. Salt wasn't just for preserving food, not at all. Folks would brush dissolved salt solutions onto wood in barns, storage sheds, and all sorts of coastal buildings to keep insects and mould at bay. Now, while salt does attract moisture when it's out in the open air, in sheltered environments it actually creates conditions where rot organisms just can't survive. These days, this technique is still useful in dry barns, storage rooms, or loft spaces, especially where you can control the airflow. It's important, though, never to use it on wood that's exposed to the elements. But in the right context, it still works surprisingly well. Proper seasoning, you see, ended up replacing chemical protection in wartime lumber yards. Funny thing is, perhaps the most overlooked preservation method was simply giving it time. Back then, wartime lumber was often air-dried for years before it was ever put to use. If wood holds on to its internal moisture, it'll rot no matter what you treat it with. WWII builders knew that seasoning wasn't optional. It was absolutely essential. Modern builders can, really benefit from this by allowing lumber to acclimate fully before construction, especially when it comes to outdoor or structural use. No preservative honestly works if moisture remains trapped inside. Elevating structures above ground prevented rot better than, any coating ever could. Instead of just relying on treatments alone, wartime designs physically separated wood from moisture. Structures were raised on stone, brick or metal footings whenever possible. Even just a few inches of elevation, believe it or not, dramatically increased lifespan. This principle still applies today. A simple gravel bed or a concrete pier under a shed, for instance, can add decades to its life without a single chemical treatment. Ash and lye washes discouraged insects and fungi simultaneously. Wood ash, mixed with water or lye, created alkaline washes used on barns and storage structures. These washes neutralized fungal spores and deterred boring insects. While not permanent, repeated application maintained protection with minimal resources. Used carefully today, ash washes are effective for non-decorative structures and align well with sustainable off-grid practices. Wartime joint design prevented water intrusion before it started. Rather than sealing water out later, World War II builders designed joints that shed water naturally. Sloped surfaces, overlapping boards and drip edges reduced exposure. This passive approach preserved wood longer than any coating alone. Applying these design principles today is, one of the most effective long-term preservation strategies available. Maintenance schedules, they really replaced what we call replacement culture. During the war, absolutely nothing was disposable. Wood was inspected, cleaned, resealed and repaired early on. Small problems, well, they never became catastrophic failures. This mindset, honestly, is still the most powerful preservation tool available to us. Modern preservatives, they often promise decades of protection, but they tend to fail when moisture gets trapped beneath synthetic coatings. WWII methods, by contrast, focused on breathability, dryness and biological resistance, not just surface perfection. When you combine these approaches, they routinely preserved wood for half a century, or even more. If this kind of hard-earned historical knowledge matters to you, well, this channel exists for exactly that reason. These techniques, they weren't developed in laboratories. They were really forged under pressure, scarcity and real consequences. If you found value in this breakdown, subscribe to the channel, share this video with someone who still builds things to last, and let's keep these lessons alive.